This is your presenter Asloob Mudassar, and I am presenting slide number 129 of the course on laser physics. Question is, Q switched pulses can be obtained when the pump rate is pulsed or the pump rate is continuous. Discuss the dynamics of Q switching under these two modes of operations. The answer is, let us first discuss the operating regime during the pulsed operation. That is, when the pump rate Rp as a function of time has a pulsed form. Duration of the pulse should be comparable to the upper state lifetime tau of the active species of the laser medium. During the pump pulse inversion, n as a function of time starts increasing and reaches the maximum value ni. When the inversion is at its maximum value, the Q switch is set to the open state at time t is equal to 0. So let me show you the description given in the paragraph in the form of a figure. The caption of the figure 1 is time behavior of a photon pulse phi of t, inversion n of t, and losses gamma of t in a Q switching under pulsed pumping. So here I am going to show you the pulse, pump pulse, that is Rp as a function of time. So this is the pump pulse. And we are taking this pump pulse before the time t is equal to 0. So this pump pulse occurs in the time when t is less than 0. Because we are setting our reference over here for t is equal to 0, and t is equal to 0 will be the reference when the Q switch is in the open state, is set to the open state. So here we have a Q switch in the closed state, and the pump pulse appears as, you see that in the pump pulse, the rate of the pump is increasing, reaches to the peak value over here, and then decreases and ultimately becomes 0. This is one pulse from the pulsed pump, and this is called the pump rate as a function of time t. And you see that during this pulse time, look at the population inversion n as a function of time. When the pulse starts, the population was at its minimum position, that is nf. So when the pulse rate increases, you can see that the inversion also increases. And when it reaches to the peak value, the population inversion also approximately reaches to its peak value, which is ni, that is the maximum value of inversion under this pump pulse. So ni is the maximum value of the inversion achieved with the pump pulse given over here. So you see that it stays constant, and when the pulse falls to 0, that is when the rate of a pulse decreases, then of course the population inversion also decreases. But we are not going to discuss and associate the decrease in inversion. We cannot associate the decrease in inversion with the pump rate or with the pump pulse. But simply see that during the maximum, because you see that here we have the maximum value of the pump rate, which also nearly corresponds to the maximum value of the inversion, which is nearly ni. And for this region of the pump, which is still a pumping process, but you see that the pumping process is slowing down and is falling to 0, still we have the inversion to stay over here to be constant, nearly constant, or slightly increased from its value at the peak. So here is the peak, and the corresponding value to the peak is over here. And you see that ni value is slightly greater than the value corresponding to the peak of the pulse of the pump pulse. So this is the value where the inversion stays constant due to the pump rate still exists, though it falls to the zero. And you see that here I have shown the three values of the inversion: NF, NP, NI. NI is the maximum value of the inversion, and I shall be explaining NP and NF in after explaining it through this paragraph. The number of photons starts increasing during the time t greater than 0. So you see that the Q switch is set to the open state. When the Q switch is set to the open state, then the number of photons starts increasing during the time t greater than 0, while the photon peak occurs at a time t is equal to tau d. And tau d is the time where the inversion decreases from its maximum value Ni, which is the value also regarded as the initial value at time t is equal to 0, to a value Np at time tau d. So when the inversion falls from its initial value Ni to its value Np, then the time taken by that one is regarded as the tau d. The inversion left at time t is equal to tau d is not enough, which leads to the decrease in photon number, and the inversion finally approaches to the value Nf. So let me explain this paragraph with the help of the figure. So look at the inversion. The inversion reaches to the maximum value over here, and when it has attained a maximum value equal to Ni, then you see that the Q switch is set to the open state at time t is equal to 0. So this dotted line indicates the time at which the Q switch was set to open state. So when it is in the open state, what happens? So it is not the fall of the population inversion is not associated with switching the time. The population inversion has to decay automatically. So this population inversion starts falling. That is, the population inversion is going to decrease. And you know that when the population inversion decreases, it means that it contributes number of photons in the cavity. And at the same time, look at the phi as a function phi of t. The number of photons increases. And at some time, which we call as the time tau d, the inversion decreases and the photon pulse reaches to its peak value. So corresponding to the peak value of the pulse, the inversion is regarded as the NP version. So NP is the version corresponding to the peak value of the pulse. So this P stands for the peak value. So NP, which is the peak value of the inversion, NP is the version which corresponds to the peak value of the pulse. And after this one, when the inversion has fallen to the value Np, after that the inversion is not enough to contribute number of photons in the further number of photons in the cavity. But still the inversion is going to decrease, and still it is contributing the number of photons, but the number of photons are falling. And with the and when the inversion decreases to its minimum value or the final value nf stands for the final value of inversion, then of course the pulse has decreased to its minimum value. That is, the photon number of photons has decreased to its zero value. So you see that a pulse is created. Then pulse starts when the inversion starts falling, and the pulse reaches to its peak value corresponding to the value of the inversion, which corresponds to Np. So Np is the inversion corresponding to the peak value of the pulse of the photon pulse. And when the inversion further decreases to its minimum value Nf, number of photons will also decrease and ultimately become zero when the inversion reaches to its final value, which is Nf value. And here I have shown delta tau p as the line width of the photon pulse. And tau d is the time taken by the photon pulse to reach its maximum value or the peak value. So let me explain one more curve over here, which is the gamma of t. Gamma of t is actually represents the loss in the cavity. When you see that before the time t is equal to 0, we have these regions which correspond to the condition when the Q switch is in the closed form. So when the Q switch is in the closed form, the value of gamma C, which is the critical value of the loss, is very high. So when the Q switch is set to the open state, the value of the losses suddenly falls to its value, which is gamma naught. So gamma naught is the value of the losses at the steady state value. So gamma naught is the steady state value of the losses. That is when the laser operation has started, that is the pulse is starting building up in the cavity. The value of the losses appears to be gamma naught. So gamma C, which is the value, which is a constant value when the switch was closed and when the switch was open, the value of the gamma, the value of the losses then falls to its steady state value, which is gamma naught. And when the gain, that is when the gain curve remains greater than the value of the losses, then of course there will be a contribution to the number of photons in the cavity. But when the gain of the system becomes smaller than the loss, then of course the lasing action starts due to this process. So now let me read this paragraph again so that we can really understand what is happening. Number of photons starts increasing during the time t greater than 0. That is the time when the Q switch is set to the open state. While the photon peak occurs at a time t is equal to tau d, and the inversion decreases from its maximum value Ni to its value Np at time t is equal to tau d. So this Ni is actually the maximum value of inversion, or you can say that it's also the initial value of the inversion which is used for the start of the pulse. That is, the pulse starts at the value of Ni. When the inversion is Ni, this I stands for the initial value of the, or the starting value for the pulse, or the initial value for the pulse. So the pulse starts when the inversion reaches to the value Ni. And you know that Np is the value when the pulse reaches to the peak value. The inversion left after time t is equal to tau d is not enough, which leads to a decrease in photon numbers, and the inversion finally approaches to the value Nf, which is the final value of the inversion. You see that here we can say that this NP, if you look at the previous slides, the previous 2-3 slides, you will see that we have used the word NC instead of NP, and NC is the critical inversion. So you see that the peak occurs at the critical inversion, and here we have used the value of NP because the value of NP means that this is the inversion value corresponding to the peak value of the pulse, of the photon pulse. And this in principle is actually the critical value of inversion. And when the inversion falls to the critical value, then the lasing action will stop, and then you see that the stimulated absorption will start, and the number of photons will start absorbing, so the number of photons decreases in the cavity. So it is the maximum at the value of the critical inversion, and when the inversion falls below the value of the critical inversion, then of course the stimulated absorption takes place, and then of course the number of photons in the cavity decreases. So you can also state that when the photon increases, this is because of the contribution of the stimulated emission. The population inversion will fall and the stimulated emission takes place, and the number of photons in the cavity increases to the peak value, and when the stimulated absorption starts, then the pulse falls to its ground value. So I have explained this paragraph. Now let's go further and read this paragraph. When the Q switch was closed, before the time t is equal to 0, the inversion attained its maximum value ni, while the cavity losses gamma as a function of time, which is the cavity losses, stayed constant. On opening the Q switch at t is equal to 0, the cavity losses drops suddenly from the constant value gamma c when the switch was closed to a lower constant value gamma naught when the switch was opened. So gamma naught may be associated with the cavity losses. So O with gamma stands O naught stands as the when the switch was opened, and C stands for when the switch was closed. So this gamma C can be regarded as the losses of the cavity when the switch was closed, and gamma naught is the losses of the cavity when the switch was in the open state. After the first pulse has occurred, the second pump pulse can be launched to obtain the second laser pulse, and the process can be repeated indefinitely. The operating regime under the pulsed operation is shown in figure 1, which I have explained. So you see that when the photon pulse is obtained, then you see that another pulse, that is another pumping pulse, that is RP of T pulse, can be another pulse can be initiated for the for this process to be repeated and for the second photon pulse to be obtained through the lasing process. So this is how the regime under the conditions that the RP is a function of time and is in the pulse form is explained. Now we go to the next step where we are going to explain the continuous wave pumping mechanism and what happens under that condition. Now we discuss the operating regime during the CW operation, that is a continuous wave operation, that is when the pump rate Rp as a function of time has a constant value. So let me show you that in the next figure. Here you can see that Rp as a function of time is constant with time. The cavity losses are constant equal to gamma C, and gamma C, you know that are the losses corresponding to the state when the Q switch is in the closed state. So the cavity losses are constant and equal to gamma C when the Q switch is closed, which falls suddenly to the lower constant value gamma naught when the Q switch is opened. That is, gamma of T has periodic variation between the two fixed values gamma C and gamma naught when the Q switching is periodic. So when the Q switching, that is you close the switch and you open the switch, then according to that periodicity in the Q switching, then the losses also switch periodically. That is from gamma C to gamma naught and from gamma naught to gamma C. Corresponding to each Q switching operation, there are Q switched pulses. So let me explain the behavior of the losses, which is shown over here. So the plot of gamma t versus time is shown over here. And you see that I have shown two values of the losses. One is gamma c, the other is gamma naught. Gamma c is the loss of the cavity when the switch is closed. But when the switch is opened, then the loss falls to the value which is gamma naught. And again, when the switch is closed, the value increases to the value gamma c. And then when the switch is opened, again the value falls to value gamma naught. So with the switching, with the periodic switching of the Q switch, the losses also switches to gamma C and gamma naught, and from gamma naught to gamma C. Whereas the RP as a function of time stays constant, that is the pump rate stays constant with time. Each pulse starts when the inversion has reached its maximum value Ni, or Ni you may regard it also the initial value for the start of the photon pulse. or here you can also say that it is also the maximum value of the inversion, and reaches to the peak value when the inversion drops to a value np. That is, the number of photons in the cavity reaches to its peak value when the population inversion falls to np, because the np corresponds to the inversion value, which corresponds to the peak value of the photon pulse, and the pulse is completed when the inversion has fallen to its final value nf. So let me explain that one through the figure. So you see that when the switch is closed, that is gamma c, in the region of gamma c, the inversion increases from its initial value nf, that is the final value of the inversion when it falls. So nf is the value, the minimum value, then the inversion increases to its maximum value, which is ni value. And when the switch is opened, the losses the loss falls to its value gamma naught, and then of course after reaching to the maximum value of the inversion starts falling, and when it falls, what happens? The peak, the photon pulse starts. So the starting of the photon pulse is corresponds to the time where the initial value of the inversion starts falling, and the peak value of each photon pulse corresponds to the value of np. When the population inversion is np, the photon numbers has reached its peak value. And after that, when the inversion further decays, then of course the number of photons in the cavity are falling, and of course the pulse is also decreasing. So for each time the switch is opened, that is the gamma c reduces to the value of gamma naught, then the inversion starts falling, and then of course another pulse starts increasing, that is the photon pulse is appearing, reaches to the maximum value corresponding to the value of the inversion at np, and then of course then the photon pulse decreases to the value of 0, with the value of inversion going to be equal to nf. That's the final value of inversion. So you see that after each time, after the value of np, when the inversion further falls, then of course this is the process where the stimulated absorption takes place. And you see that when the inversion increases, it means that this is due to the stimulated absorption process. So after the value of np, the stimulated absorption effectively starts, and that's why the number of photons in the cavity decreases. And when the number of when the stimulated absorption further starts due to the pumping process, the inversion starts increasing to its maximum value. And when the inversion starts falling, it is because of the stimulated emission process. So the fall of the inversion from its initial value Ni to the final value to the value Np is due to the stimulated emission process. And from the Np value to the downward, the inversion starts falling further because the number of photons in the cavity are decreasing. And this is the region where the stimulated absorption also starts initiating. So under the constant pumping, the inversion again starts building up towards its maximum value Ni in a time equal to the lifetime tau of the upper state. So this is very important. That is, the inversion will increase up to the lifetime tau of the upper state. And when the inversion is, when the pump is pumping the inversion, and the inversion increasing for the time tau, which is equal to the lifetime of the upper state, then the Q switch is set in the open state. Because if the population inversion further increases, what will happen? This is explained here. The pulse repetition time tau p should be equal to tau or slightly shorter than tau. If tau p is greater than tau, the inversion will start falling due to the spontaneous emission process. So you can notice over here that tau p is the repetition time of these pulses, and this is the time which is also equal, which is should not be this time tau p should not exceed the tau, that is the time which is the lifetime of the upper state of the laser. Because if this time exceeds, what will happen? The population inversion will decay through the spontaneous emission process. And if Q switching occurs further, then the peak value of the pulse will be shorter, because some inversion has been lost during the spontaneous emission process. So this tau p is very critical and should not exceed the value, but it should exactly match with the value of the population, with the value of the lifetime of the upper laser state for optimum value of the peak. Fast mechanical shutters, electro-optical, for example, electro-optical shutter and the saturable absorbers are the shutters which are normally used in pulsed operations, whereas the medium speed mechanical shutters and the acousto-optical based shutters are used in the continuous wave laser operations. And these techniques have been explained, these Q switching techniques have been explained in the previous slide, that is in slide number 128. In pulsed operations, the repetition rate falls in the range from a few hertz to a few tens of hertz. Whereas in the continuous mode operation, the repetition rate falls in the range from a few kilohertz to a few tens of hertz. From a few kilohertz to a few tens of kilohertz. The operating regime under the continuous pumping operation is depicted in figure number 2. This is the figure which I have explained, and this that corresponds to the case when the value of the pumping rate is constant with the time. And you see, and this is the region where we discuss the continuous Q switching operation. This is the Q switching operation is occurring repeatedly or periodically, and the pulses are obtained, and the photon pulses are obtained periodically. And you see that this was the case when the pump rate is in the form of an impulse or in the form of a pulse. And you see that over Q switching starts, that is we set the Q switch at the time t is equal to 0 to be in the open state. And at that state, the important thing to note is that the losses in the cavity gamma c falls to the losses gamma naught. So this is what we have explained. The question raised in the beginning. So this is the end of slide number 129.